All right. Well, good morning, everyone. Welcome to today's Exploring by the Seat of Your Pants event. My name is Joe Grabowski, and I'll be your host for today. February is always one of our favorite months at Exploring by the Seat of Your Pants because in February, we kick all the men out for the whole month and we host exclusively women in science, adventure, exploration, and conservation from all over the world. So it's been a wild month so far. February 11th was the International Day of Women and Girls in Science. So we had a lot of fun then as well. And we still have just over 2 weeks of events still to come. So I hope to see some more classrooms joining in those events with us. All right, well, let's get to today's event. We've got Debarati joining us today. She is a graduate student at McGill University in Canada. She's a member of NASA's Mars Science Laboratory team and studies rock chemistry and habitability of the planet Mars using the Curiosity rover. So she uses the laser instrument on the rover to measure the element boron in the Gale Crater on Mars. And this can tell us a lot about past water activity on Mars. So she also goes to different places around the Earth to sample rocks from areas that might resemble spots on Mars. And recently she visited Death Valley to do just that kind of sample collecting. So Debarati, it's so awesome to have you joining us live today. We're excited to get to know you a little bit better. And of course, the kids are going to take over and fire some Q&A at you.
Perfect. Thanks for having me. Well, let's get okay. There we go. Okay, can everyone see my screen? Okay, great. Perfect. Let's start the slideshow. Okay, so today I'm going to talk about chasing water on Mars with lasers. You can see my entire screen, right? Am I blocking a part of the screen?
No, you're full on. Looks good.
Okay, perfect. All right. So, who am I? I'm Debarati. I'm a graduate student at McGill University, as Joe mentioned, and a NASA Mars Science Lab team member. I'm also a National Geographic explorer. I study these veins on Mars using the Curiosity rover, and I've recently started helping out with the SuperCam team on the Mars 2020 mission. So very small. I'm just on the list, sort of helping out, hoping that will increase over the time. And I recently went to Death Valley, and let's see some of the cool things that I saw on Mars and on Earth. So what exactly do? I study water-soluble elements on Mars, elements that are very easily dissolved in water, like boron or lithium, rubidium or strontium. And I look at Martian rocks to understand these water-soluble elements, and I use the laser instrument on the Curiosity rover, and I do this to understand past water activity on Mars. So so far I've been specializing on this element called boron. It's the fifth element on the periodic table, and I've been doing this because boron is quite a special element. It's very water soluble. It's associated with neutral water, water that's not too acidic, not too alkaline, and it's also associated with molecules that support early life on Earth. So that comes up with a really interesting potential for habitability on Mars. So why exactly is this important is because we also recently found a whole bunch of boron in these vein-like materials on Mars. This is an image from the surface of Mars that the Curiosity rover took. And these veins that you see are actually this mineral called gypsum that we have on Earth. So here's an example of gypsum. It's a beautiful specimen I have. It's transparent almost, as you can see. And we often use this in plaster of Paris on Earth, and they're lamps made out of selenite. So these are rocks and minerals that are very similar to things we have on Earth. And here's a sample I collected from Death Valley, which looks very similar to what we have over here. And I collected these samples just to understand what Martian samples would be like, because we don't have any geologists on Mars yet. Okay, so this is important because boron is water soluble. So the fact that we have boron, it might mean that there might have been water around. So that, and water, wherever we have water on life, we see algae, we see bacteria, we see other things that want to survive off of water. So water means there's a potential for life, and that potential itself on Mars is pretty amazing. So let's take a virtual field trip to my field area on Mars. So this is Mars, and I've used Google Earth here, so you can go on Google Earth and search for yourself where Gale Crater is. Oops, where the crater where the Mars 2020 mission will land is. So let's dive in. So we're focusing on Gale Crater here, and you'll see an ellipse. The ellipse is the landing ellipse for the Curiosity rover, and it did a great job. It actually landed quite close to its estimated target, and you'll see all these names popping up. So these are names that are given by scientists to identify the different features in Gale Crater. So this red line you see is the path the rover took to sort of go towards the center of this crater. It's not updated yet, but right now I think the rover is somewhere around here, and it recently crossed this little ridge. The closer and closer we go, you see all these interesting features of flow patterns. It looks like a riverbed that, you know, it points to an evidence that there might have been water, there might have been a lake at this position on Mars. And the rocks underneath potential water that may have been around stores a lot of information about what the composition of the water may have been like. So the main goal of the rover right now is to eventually reach the central mound of the Gale Crater. And that's super interesting because this crater may have once upon a time been filled with water. So this central mound that is formed, it's probably formed because of the water that sat around there for a long while. So let's take a look at that. So here's a static image of the crater itself. And the central mound, called Mount Sharp, is around 5 kilometers high. So imagine how much water there might have been and how long it might have been to just accumulate 5 kilometers of sediments, you know? So we want to know what the rocks look like, what information it's stored, what the water may have been like. Is there a potential of life at all? But how exactly do I study any of this? Well, lasers. So this is the Curiosity rover, and this is the ChemCam instrument on the rover. And the ChemCam instrument has this instrument called LIBS. So LIBS stands for laser-induced breakdown spectroscopy. Basically, it shoots lasers at rocks, and let's see how it does that. So on the, what is this, the left side, you'll see the picture of the laser shooting a beam at the sample. By that, I mean a rock. And then this high-powered laser turns the rock into the fourth state of element called a plasma. And the plasma has all the information, all the chemical information about the rock. And there's a detector on the other side, and it sort of takes a picture of this plasma. And plasma tells us all about what's in the Martian rock. So this image that you see, this moving GIF of this spot that you're seeing, it's actually an image from the Martian surface. The laser on Mars is shooting a little hole to analyze what kind of composition is in Martian rocks. So why is there boron on Mars, or these water-soluble elements? Is it a similar cycle to evaporites? How borates form on Earth? Are the Martians cleaning their windows with borax? Well, let's look at all the results that I've found and sort of cartoon diagram of understanding where exactly it's coming from and what's the history of Martian boron or water-soluble elements. So this is a cross section of the Gale Crater. This is the central mound that we saw, the Mount Sharp. We think that the Gale Crater formed because of an impact, and the impact sort of caused cracks at the base of the crater, and at a time which was wetter and warmer on Mars, there was rain, and this rain sort of brought all the sediments in and started making these layers. Eventually, it stopped raining and the water started to dry out. So it enriched salts in it. So if you've seen salty lakes, it's really dry, and it just, when all the water dries out, it forms all these crusty salt bits. So we think something similar happened in Gale Crater, and the water started becoming more and more salty. So the cracks that were in the bottom, the bed, how would the base of the crater sort of started storing this water, and eventually also started getting salty. And when the water completely evaporated, there wasn't a lot of protective layer on top of the sediments that was left behind in the craters. So wind came in and sort of eroded away bits and pieces of the sediments inside this crater. But the water underground still remained. When the evaporation, or when the winds took away the overlying pressure of the sediments, the water from the bottom started pushing into the rock above. So this water got into the remaining sediments, and that also eventually dried up. So this water is what was the last remaining bit of water on Mars, and what it left behind is our complete list of elements of what Martian water could have been, except for the things that evaporated, of course. So this is our snapshot of Martian water, and that's why we're studying these. Unfortunately, it's too early to have a geologist on Mars right now. So the closest we can go is look at a feature on Earth that is similar to that of Mars. So a place that I've thought would be really similar is Death Valley, because it has dry and wet cycles like that of Mars. And we see a lot of these similar veins. This one is a particular favorite of mine because it, always reminds me of an ice cream sandwich. You can see this clay-ish material over here, and you can see this beautiful white evaporite mineral. When I say evaporite, it basically means minerals that form because of water evaporating. So this is a borate. It's not a sulfate, as we see on these images over here, but it still gives us a good idea of the physical ways it forms, what kind of compositions it might have. So that National Geographic gave me a chance to visit Death Valley. I went last summer and it was really fun. I got a whole bunch of samples, and this is one of my prized samples that I'm still working on. Well, there are far more exciting, there's a lot of exciting news coming from the rover side of the team. There's going to be an exciting new mission, Mars 2020. The planned launch is on 17th of July. So if you're in Florida, you can go and watch the launch. I think the name of the rover has also not yet been finalized. So you can look forward to having a brand new name. Did any of you guys send in names for the rovers? Maybe you can tell me at the question and answer session. So this rover will be going to a completely new area. It's called the Gale Crater. Here is the Gale Crater. This is where Curiosity rover is, and here is the Gale Crater. And we'll get some really exciting results from there. It'll be landing in February 18th, 2021. That's the estimated date of landing. And there's a future plan for sample return mission, and it's lots to expect from there. Well, so you can stay involved. You can constantly check the websites, which give the status updates of the two rovers. You can also interact with Rovi, ask your cool space-related questions, and find activities you can do in class. You can build your own rover. You can induce the atmosphere of Mars by adding in a little jar, by like lighting a candle and getting carbon dioxide and seeing if the candle stays, because Mars is made out of carbon dioxide, the atmosphere. So there's so many things you can do and stay involved. And if you're looking for things you can do I think all of you are about 10 to 14. If you're thinking about how you can get more involved in space related activities, if you like space science a lot, and if you're thinking about choosing career paths, I think it's a little too early for you. But if that thought has crossed your mind, there's so many things you can do. You don't have to become a scientist or an engineer. You can become a scientist or an engineer. You can become an astronaut, a science communicator, a science journalist, a museum curator, even an artist or a fashion designer. So all these amazing women, the pictures of amazing women over here, these are real people. Some of these are also my friends. So if you have any questions about how can you look into becoming a scientist or a fashion designer, you can ask me more questions and I can get you in touch with these amazing people who are ambassadors of space science. Well, with that, let's take some questions.
All right, sounds good. Debarati, do you want to hit the stop screen share at the top and come back to us?
Yeah, that would be great. Perfect. There
Perfect.
we go.
So before we start meeting some of the classrooms, do you want to show those samples again while you're nice and full screen so we can get just a little closer look at some of those really cool
thing. So here are my samples from Death Valley. These are some clay-rich rocks surrounding the beautiful white borates in the middle. Almost looks like an ice cream sandwich. And these are one of my favorite samples. Can you see these? Are we? Yeah.
Yeah, you can definitely see the ice cream sandwich appearance. And then, so can you just hit us again with what that's telling you when you find that nice rich layer of borate?
Yeah. So I did have some of the samples that have sulfates. So what I'm looking for is sulfates with boron in them, but it's not as pretty as this. So this sort of gives us an idea of what the water that made this layer could have carried, and its interaction with the surrounding rock too. So this entire layer was probably made by a water really rich of soluble elements like lithium, boron, barium, strontium, and all that is stored in this nice thick layer. And when we sort of do an analysis, we do a chemical analysis throughout, we can see how the chemical interaction is changing between these rocks and this super water soluble element rich layer. So that gives us a great snapshot of what exactly happened. So,
all right.
Good analog.
It's really cool how our Earth really does keep a really cool history that we can look back at, we can read when we dig deeper into the rock layers. And it's even more exciting that we can use some of that to think about other planets as well.
Exactly, precisely.
I think that's pretty cool. And not a lot of people can say that they use a laser on Mars, shoot it at rocks to find out what they're made of. That's pretty awesome.
Right? I think so too.
All right, very cool. Well, I think it's time to start meeting some of our live classrooms. So let's get going. I want to give a shout out though to Miss N's class from Georgetown, Ontario, who's tuning in live via YouTube. Looks like we have another group from Brantford, Connecticut. But let us start meeting our live classrooms. So we're going to go to Mrs. Metcalf's group first, grade 6s hanging out in Salem, Illinois. Let me get that microphone turned on. How are we doing, grade 6s?
Good. Yeah.
All right, here comes someone.
Hi.
Hi, I'm Jordan. So my question is, when do you think we will get to Mars?
Well, do you mean humans? When are humans going to get to Mars?
Yes.
I personally think we still have a ways to go because we still need to understand a lot about the planet itself. There isn't much to survive off of. The atmosphere is made of carbon dioxide, so we have to think about how to transport a whole bunch of oxygen, food, and water to survive there. So Elon Musk may say maybe we'll take 5 years, but I think we'll take a little longer. Hopefully in our lifetimes, we'll see someone go to Mars and find cool things. Great question.
All right. For now, we're just going to have to be happy with the rovers. And they keep getting cooler and cooler. And I'm looking forward to a mission where samples can be sent back. I think that's going to be pretty incredible to get those samples right from the surface.
Exactly, yeah.
But just building on that question, let's say you woke up tomorrow and someone said, you can go to Mars. Would you take that trip?
I know. I like Earth food a lot. And I like being part of the missions. But if you watch The Martian, life would be unstable on Mars right now, at least for humans. It's full of carbon dioxide. It's a struggle. And we haven't quite figured out how to stabilize human health on space. As you know, the gravity varies, so it causes all sorts of problems with muscle atrophy. And I guess I'm a little too scared. I'm not as brave as some of the astronauts we have out there.
All right, I think that's perfectly fair. There'd be a lot to think about, the amount of time, effects on the body. We do have a lot to figure out before we do a mission like that.
Exactly, yeah.
All right. Mrs. Lackey's group hanging out with us in Freehold, New Jersey. Looks like some fourth graders. Let's get that microphone on. How we doing, New Jersey?
Great.
Hi.
My name is Giuseppe, and my question is, how long does it take to build the rovers?
How long does it take? Great question. It takes a long time. I think from planning to execution, for the new rover, I don't even know when the initial seed, the thought came in. The building process has been around a year and a half, and you could even see the live process of the rover being built on the NASA website. In fact, it has just recently moved to Florida, and the people at JPL are so sad that their rover has left for the final deployment. So I would say it takes far more than a year, especially from the conception of the idea to getting the proposal approved, to getting the budget together, getting the scientists together, and getting the engineering team together. It's a big process. But I think it's still been done in a good amount of time that we will be able to potentially see a launch in July.
All right, very cool. And that's something that can be tuned into as well. So that's definitely something that I imagine will be streamed online, and then maybe even the landing too.
Oh, that'll be great. Yeah, the landing will be in February next year, and you'll definitely tune into the launch in July. All
right. Mrs. Wilson's 8th graders are hanging out in North Riverside, Illinois. Let me get that microphone turned on. How are we doing, 8th grade?
Hi. Hi.
Oh, I love the excitement.
Hi. So I have a question for you, and my question is, what is your favorite type of rock off of Mars?
My favorite rock. Awesome question. I think I'm a little biased, but I love evaporites on Mars. By that I mean minerals that are left behind when water evaporates. So that's what I'm studying. I'm looking at gypsum or sulfates, and we get a whole bunch of it on Earth. And look how just look how beautiful this is. That's a gypsum. And we get to know about potential of life, about water, and all these neat things on Mars. So that'll be my answer for my favorite kind of rock from Mars.
All right, very cool. Good question. So we're going to go now. We're going to visit a class in Connecticut, Stafford Springs. We'll start off. There's 2 groups joining us from there. We'll start off with Mrs. Bontempo and Miss Miller's group. Let me get their microphone turned on. How are we doing, Connecticut?
Good.
Hi.
I have a question for you. Does the rover come back on Mars?
I mean, it goes to Mars, but unfortunately, we don't have any plans to bring the rover back to Earth. However, for Mars 2020, there's a future plan of retrieving samples, and I read up on it this time. So the whole plan is that there'll be eventually, so this rover will go around drilling some samples, little cores, and eventually there'll be a lander will just sort of like sit around on Mars, and NASA will collaborate with the European Space Agency to make another rover, which will be called the fetching rover. So that rover will go around collecting the samples that the Mars 2020 rover collected and bring this back to the lander, and that lander will shoot a lot. I think a launcher with the samples, and then there'll be a rendezvous to collect that sample. So we can't bring the rovers back, but there is a future plan to bring back these little samples that the rover will collect, which will be incredibly exciting because that'll be the first time it will be a sample return mission from Mars.
Yeah, wow, that's a lot of, I mean, it's amazing. All that engineering, that science for a mission like that, to have the initial rover collecting, another one picking up those samples, launching, and then picked up in inside the atmosphere. That's quite a mission. That would be pretty amazing.
Right? That sounds incredible.
Yeah. And then, so the rovers, obviously they're designed, they last for a finite amount of time. They have solar panels, so to use that sun's energy. But the last few, they've lasted quite a bit longer than expected, didn't they?
Yeah, I think Curiosity does not run on the solar. It's not solar powered, which is why it can survive in a dust storm. I think Mars 2020. I'm not going to give you wrong information. So I'll have to look this up. I don't know what Mars 2020 is powered by, but I think it's not using solar. I think that's why we lost opportunity to the dust storm, because that's one way to sort of lose contact. But it outlived its lifetime, and so did Curiosity. I guess the engineers are being very cautious when they're assigning its lifetime, but these instruments have done really well in terms of their lifetimes.
All right. Our second group in Connecticut, let's see. Uh-oh, why don't I see them? Oh, there it is. Okay, let's get that microphone turned on. There we go. Mrs. Barnes group, your microphone is on in Stafford, Connecticut.
All right.
Hello. I am Trent, and my question is, if anyone does land on Mars, do you think it would be possible if they dig to the center of Mars from one of the craters? Do you think it's going to be possible to find a water source to bring back the water?
Ooh, sorry, find a water source that you could. I couldn't hear that. Bring
Mars?
back.
I think I can help a little bit with that.
Yeah.
I think he's wondering, if you dig deep enough, get into a crater and dig deep enough, could we find some sources of water? Do you think there's still water?
Great question. There's actually water trapped as ice underground on Mars. This was found, I think, last year sometime, and it was really exciting. There are thick layers of Martian water ice that are on the poles and nearby. So if you might not even have to dig that deep to get access to these water ice. And if you put that in a bottle and you melt it, I'm sure you can bring it back. Hypothetically, if you were a geologist or an engineer on Mars, trying to get back a little souvenir of Martian water.
All right, so I've got a question from YouTube. We've got a group tuning in. Where are they tuning in from? Georgetown, Ontario, so not too far from us. And they're kind of got like a two-parter. They're wondering, can the rover measure radiation on Mars? And do you have like a ballpark estimate on the cost of a rover?
Cost of a rover. So I think the current rover cost, the whole plan was around $2.4 billion. I'm not sure if that's just the cost of the rover parts and how you pay the scientists, but I remember from reading an article that the sample return mission was around $2.4 billion, which is a lot of money. And to answer the first part of the question, direct radiation measurement, I think there are instruments that are remote that measure radiation. And to some extent, the rover can measure radiation using the rover. Yeah, I think the APXS instrument, which it's a Canadian contribution, may be able to measure radiation given off of Martian rocks.
All right, very cool. So let's do this now. We still have a little bit more time. So if there's another question in your classroom, why don't you send someone up to the camera, and that'll be my cue that we need to visit your class at least one more time before we wrap up for today. So I see someone in Mrs. Wilson's class. Let's get started with our 8th graders.
What interested you about this career?
Great question. So I started my studies with just looking at rocks, geology, rocks on Earth, different kinds of rocks, different kinds of minerals. And I was looking at Himalayas, and I got a chance to go for an internship to Japan to study meteorites. And when I studied that, I thought it was pretty incredible that we have access to rocks that formed far away from us a long time ago, and may even give us answers to where life began, where we all came from, you know? And then our personal problems just feel so insignificant. So it's a way to keep myself motivated to ask these bigger questions. Where did we come from? Where are we heading to? And I found Mars after I studied meteorites, and I keep doing that because it's exciting and we have so many new things to discover.
All right, great question. Mrs. Miller and Bontempo's group, your microphone is on.
Are you able to bring water to Mars and then dump it on it? Would it just like evaporate instantly?
Good question. Well, water right now, we don't find a lot of water on Mars because the atmospheric condition is such that it doesn't support liquid water. It can't. Liquid water is not stable. It does immediately evaporate. So if you do bring water on Mars, it'll have to be a lot of it so that it sort of forms an atmosphere of oxygen and ozone, and sort of has a water pressure enough to retain the water on the surface. So yeah, it will. If you dump a whole bunch of water on Mars right now, it will evaporate, unfortunately.
All right, Mrs. Metcalf's class. I see someone waiting patiently.
Hi, my name is Kaya Garrison. I have a question. Do you ever see signs of erosion on the rocks you study?
On Earth or on Mars?
On Mars.
Yeah, great question. There is water-related alteration. There's wind-related erosion. In fact, we recently crossed this ridge called the Vera Rubin Ridge in Gale Crater. It's just a sort of a little hill on Mars, which a lot of scientists think is because of the erosion from wind. So when wind constantly kept hitting the sediments on Mars, and there was this one specific area that was higher in hardness, so it just kind of sticks out. So yeah, we see a lot of erosion on Mars. It's a great question, and it tells us, the kind of erosion tells us if it was done by wind or water, what exactly happened there. So yeah.
All right, good question. We're going to swing back to New Jersey. Let me get their microphone turned on.
Hi.
How does curiosity survive the solar storm?
I think it sort of hangs around a little bit. It's not solar powered, so we sort of sit there and hope that the solar storm hasn't upset any of the instruments. And I think we also wait for communications to come back up and see what the status is, and you usually get a green status or red status, and there's constant meetings with the team members saying, what is the status of the rover? Are all the instruments have the green check? Is it operating properly? And if there are any problems, then engineers help troubleshoot these problems. So far, fortunately, Curiosity rover has not been hit fatally in any way because of the sandstorms. We did lose opportunity to it. So I'm sure that Mars 2020 will have some adjustments so that it can survive potential dust storms.
Yeah, I think that's it's a really good question. There are some wild storms on Mars, and the earlier rovers that were solar powered, if that dust settled and didn't blow off of the solar panels, that's big trouble for a solar powered rover.
Yeah.
But I can't remember if you mentioned it, but Curiosity does have a little nuclear powered source, which is pretty wild.
Yeah.
We're starting to get the technology that small that we can put it into a rover and work it that way. So that's pretty awesome.
Exactly.
We need to go to Mrs. Barnes' group. Your microphone is on.
How do you make the laser?
How do we make the laser? What a great question. So usually a laser is made out of photons. It's just light packets, very high energy light source. So when you put energy onto a crystal, it sort of transforms these wavelengths. You input a high energy of wavelengths, and then you get an output of a high energy beam. So it's basically like a very focused beam of sun rays. Like, have you ever tried to focus a sun ray into a beam to set fire onto a paper? So it's basically that, but it's very selective wavelengths, so that we can control it better, and we can tell what the stuff that we get back, we can tell what it contains. Based on the wavelengths, we can tell what elements it analyzed. So it's a crystal called Nd:YAG, which stands for neodymium yttrium garnet. So these are basically fancy words for just a crystal, lab-grown crystal that is used to focus this incoming energy into a light. So that's a less complicated way to describe a laser, I guess.
Fair enough. And I mean, clear, there's a lot of energy being focused. You think your typical laser pointer, if it shines on your skin, you don't feel it, but it looks like that one has a little bit more energy to be able to kind of turn that rock into that liquidy plasma form.
Yep.
All right. So Mrs. Wilson's class just had to leave, but they were curious about a question. So we'll see if we can work that in at the end, but I want to work in the classrooms. I can see I've got two more. I think we can squeeze these in. Mrs. Metcalf, and then we'll go back to Mrs. Miller, Bon-Tempo. So we'll start with Mrs. Metcalf's class.
Do you know if Mars has any tectonic plates?
Very good question. So there are studies that say that there used to be, that it's not a tectonically active planet right now. That's why we have the insight to understand if there are Mars quakes. So we have a probe and we're checking, are there any is Mars shaking at all? Is there any tectonic activity going on? We don't see a lot of large activity like we do on Earth. Like, we can see different continents and we can tell how they were once before. It's not as active as on Earth, but right now it is a tectonically dead planet, and we're still sort of looking into, do we have any Mars quakes? Is there any activity happening there? So stay tuned. We might get some interesting answers for you in the future.
All right. And one more time, Stafford, Connecticut, your microphone is on. Miller and Bon-Tempo's class.
What happens to the rover when it shuts down? Like, what will happen if it will fall apart, or will it disintegrate or something?
Well, it's a sad, it just sort of sits there. If humans go there later, maybe we can find it in pretty much the same state, because there isn't a lot of moisture in the atmosphere of Mars. There's a lot of wind, but there is a lot of sandstorm. I guess the rover gets covered in a lot of dust and sort of sits there alone. But it won't really disintegrate because there isn't a lot of moisture or anything moving it around. There isn't a lot of life to sort of go poke it with a stick. So yeah, I guess it kind of sits there with getting dust on it.
All right. And I think, let's squeeze one more in. I think I see someone in Mrs. Barnes' group waiting in a blue shirt.
Do the rovers stay cold? Do they turn icy, or do they stay warm? And also, I have a suggestion.
Wow, that's an important question. the rovers have to warm up too, because I think if the temperature is below the critical temperature, it might affect its ability to do analysis. So yeah, it requires a heat source to keep it to its optimal temperature. So yeah, I guess we try to keep the rover somewhat warm and not have it super cold so that it gives us good results.
And I think she had a name suggestion for the rover. She was just been thinking
really?
about it. Is that right? Were you thinking of a name?
Guardian of the Mars. Guardian of Mars.
That sounds like a great name. Did any of you give your names for the 2020 mission?
I think I see Miss Metcalf coming up. Let me turn her microphone on.
I had several students submit names, but they didn't make the cutoff for the semifinals. So.
Oh well, but that's the great thing. I'm sure there were some really great answers. I think there are 9 of them that are selected now, and they're still thinking about it. But I'm sure your names were just really great. It's just really exciting to see how much people get involved in the mission. It's really, some of the answers, I read them and they were just so inspiring. I think all of them are great names, to be honest.
All right, very cool. Well, I want to shout out to our YouTube groups. Thanks so much for tuning in live with us today. Obviously, a huge shout out to our camera classrooms. You guys were awesome. Thanks for all the great questions. And actually, I see someone just popped up really quick from Ms. Metcalf's class. Maybe they have a name suggestion or something. Let me get their mic on. Hey, bud.
Can I ask a question?
Sure,
okay,
yeah.
Squeeze it in.
Should we be careful about solar radiation on Mars?
Solar radiation on Mars, yeah. I think there's a lot of solar flares, and that affects. I'm going to assume that it does affect the instruments, and the engineers have to take proper precaution to prevent the instruments from degrading because of that. But I don't actually know a lot about it. Sorry about that. But Mars
That's okay.
does, yeah.
I think that's the important point, is that it's a massive team and not everybody can know everything, but lots of people have specialties in different things. And that's what makes a team work so well. And then, all right, New Jersey, one more time. I think I see your teacher front and center. Do you guys have another question?
No.
Oh, sorry. Well, good to see you again, New Jersey.
No, we're good.
All right. Well, Debarati, thank you so much. That was awesome. Thanks for sharing the work you're doing and helping to inspire hopefully the next generation of scientists and explorers. So thanks so much for hanging out with us today. And we look forward to joining with you again, especially when the new Mars 2020 mission takes place.
That would be awesome. Thank you.
All right. Well, the last thing I'll do is unmute the mics, boys and girls. Big goodbye and thank you for Debarati, and then we'll sign off for today.
Thank you.
Awesome. Well, thanks again, everyone, for tuning in. We're actually jumping into another space-themed event with a NASA scientist who studies aurora borealis in about 15 minutes if you want to check that out. Thanks, everyone, for hanging out, and we will see you next time.